Good morning, everyone. I'm Jess Hepburn, a research associate at the University of Glasgow's School of Health and Wellbeing. And today, I'm excited to share with you our latest research on a project that's really important to you all, even if you don't know it, urban parks. So today, we'll explore the critical role parks play in our society, how GIS technology has helped us understand park provisions, and also how we've managed to quantify park types across the whole of Great Britain. First, we're going to explore the critical role parks play in our society. Access to green space is vital. As stated by the World Health Organization, they play a crucial role in promoting both mental and physical health. Here in Scotland, research carried out by Greenspace Scotland found that 90% of urban Scots say it's important to have green space in their local area, showing we actually really feel those benefits of being in that green space. And the City of Edinburgh Council calculated that for every £1 invested in Edinburgh's parks, found a £12 return in both social and environmental benefits. So it's worth it. Green space here in Scotland is also in legislation and policy. It's perceived as an essential public asset, ingrained in national planning policies and land reform, and also contributes to community empowerment initiatives. All of this I presented for you now shows that green space is important from a social, economic, health, and environmental perspective. So for this project, we were interested in parks as kind of a subset of green space, and we define this through the OS Open Green Space dataset, where the type equaled public park or garden. After some configuration of this dataset, it allowed us to have 11,434 parks across Great Britain, equating to around 2,000 parks in Scotland. And it's important to note here that it's slightly different to Scotland due to the right to roam. We are interested in parks due to their multifaceted functions. The same area can have a range of uses and purposes. And these can vary depending on who you are, as well as the time of day, and even the weather. So, we're focusing on parks, but what are the true benefits of them? Well, they come in twofold, as indirect and direct benefits. Indirect benefits include an increase in visual aesthetics. We all know how lovely it is to kind of be surrounded by a green area. A decrease in noise and air pollution, which is ever important in our expanding urban centres, and also a decrease in the urban heat island effect. In terms of direct benefits, access to parks help with restoring psychological restoration, which is great for our mental health, as well as increasing physical activity, which is great for our physical and mental health, as well as increasing social interaction. So I'm now going to talk about how GIS technologies have helped us understand park provisions. So park-based research happens kind of across the world, and it tends to focus across three main areas. So there's proximity, so that's looking how far away you are from a park. Quantity, so looking at how much park space you have access to. And then quality, how good that park space is. When we started this project, we decided to focus on quality. However, when we explored this further, we realized that actually this might not be the best method for our research. Quality data is usually collected through surveys, and these tend to have a 5-point scoring method, so usually from very poor to very good. The nature of surveys mean they're subjective, so you're just gaining a personal viewpoint of an area, in this case, a park. Although quality research tends to focus on a whole spectrum of different attributes in parks, such as accessibility, cleanliness, vandalism, a lot of those get reduced down to a single score, and this means it's really hard for improvement and intervention because we don't know what we need to target to improve the quality of that park. The final thing about quality data is it tends to be very time-consuming and costly because of the nature of survey data, which means it's really hard to upscale to kind of a national or international survey. So we thought, no, quality data, we don't want to deal with you. Instead, we're going to deal with park types. So how park types differ is there's no hierarchy in park types. We're not saying that one type of park is better than another. We're just saying that they have different uses and purposes for different users. The nature of park type research is that it's objective. It's unbiased and kind of deals on kind of a data-centric approach. And this means that we're able to harness those diverse functions and uses, and we can capture them, meaning we can capture the multidimensionality of parks. And again, unlike quality data, it's universal. As long as we have the data sets there to create the park types, we can do it at any scale, which means the potential for national, if not international, comparisons. So, how did we do this? Well, we defined 18 park qualities. So these qualities are kind of characteristics of a park that we think are beneficial for users. And these were allocated to 5 health-promoting domains, which I'm going to talk through a bit further in the presentation. And what we decided to do was score every single park in Great Britain based on how well they satisfy the qualities that fall within these domains. So the first health-promoting domain we looked at were amenities. So amenities focus on toilets and cafes. And these are toilets and cafes both within the park, but also within a 100-metre buffer of the park themselves. We were also interested in facilities. So in this case, facilities actually focuses on sports facilities. So we categorised parks whether they had 1 or more sports facility, 2 or more sports facilities, 3 or more sports facilities, and then also whether or not they had any outdoor pursuits. So that's something like open water swimming or fishing. We were also interested in biodiversity. Now, biodiversity is a bit harder to capture at this kind of national scale. So to do this, we looked at whether or not there was a water features or a lake or a river present in the park. And then we also used tree cover as a proxy for biodiversity. And then we were interested in attractions. These are things that entice people to the park. So this includes tourist attractions, historical attractions, and then also recreational attractions, which is anything like picnic sites or play areas. And then finally, we were interested in accessibility. So how easy is it for someone to use kind of active transport or public transport to get to that park? And for this, we looked at whether or not there was trains or trams within a 100-metre buffer, and then also whether or not there was bus stops and the Sustrans cycleway. And I think this is a really good point to highlight the binary-based scoring we used. So for example, if a park has 1 bus stop within its 100-metre buffer, no cycle paths and no trams, it will score 1 out of 3 for accessibility. And even if it has 5 bus stops, it will still only score 1 out of 3 for accessibility, because it can only satisfy that 1 quality within that domain. So this fundamentally means that for every park in Great Britain, we have a scorecard that looks like this, where we're able to score the parks based on these varying health-promoting domains. And what I'm going to do now is I'm quickly going to show you a park that's near me, where I live in Newcastle, to demonstrate the kind of level of data that we have about these parks. So this is Exhibition Park in Newcastle. Firstly, we're going to look at the attractions Exhibition Park has on offer. It has a model railway, it has a play area, and it has 2 historical monuments. And then in terms of facilities, which again is focusing on sports facilities, we have 3 tennis courts and a bowling green. Then in terms of amenities, we have got toilets there and a cafe. And then accessibility-wise, as I mentioned before, we use that 100-metre buffer, and we have a series of different bus stops around Exhibition Park. And then in terms of biodiversity, we've got a boating lake and also that tree cover. So I think this just really highlights kind of the level of data that we used, especially as we were looking at kind of a national comparison for this. So what does Exhibition Park score on our scorecard? Well, we can see that it's relatively high across all 5 of domains. And this shows it has a range of different purposes and uses to a lot of different users. And now, here's another park close to me at home, Town Moor. And we can see just by looking at the map of this area that it has a lot fewer features there to entice visitors. But we're not saying that this is a bad park, we're just saying it's a different type of park compared to Exhibition Park. And again, when we look at the scorecard, we can see that this has captured those differences compared to Exhibition Park. This is further highlighted when we compare 2 images of these parks. The park at the top is Exhibition Park, so kind of the high-scoring park, and the park towards the bottom there is Town Moor, which is kind of a low-scoring park. So we've managed to capture all of this data about parks in Great Britain and their various qualities and characteristics. So I thought it'd be quite good to give you some stats on these, just to show you kind of what the state our park's in here in Great Britain. So I'm going to start with kind of the lower values, and this is looking at those qualities that I mentioned. So 2% of parks in Great Britain have a cafe within it, which, I don't know about you, that somewhat surprised me. I enjoy going for a walk, getting my flat white coffee. I was surprised that, there weren't more cafes in parks. And then 10% of parks have a toilet within it, so kind of moving into the higher percentages here. In terms of 21% of parks, so 21% of parks in Great Britain contain at least one sports facility, and 43% of parks have a recreational attraction. So this is quite nice to see. 43% of parks have like a play area or a picnic area in them. And now we're going to move on to the higher scoring percentages. So 61% of parks have at least 20% tree cover, which was quite nice to see. And then 68% of parks. So this is the highest scoring quality. This is the most common quality a park has. And that is a bus stop within 100 meters. And again, that was quite nice to see that our parks are somewhat accessible to people. So now I'm going to move on to talking about how we've quantified park types across Great Britain. So the first thing we noticed when we looked at the scores of the parks is there were actually some parks that scored 0 across all of the qualities and therefore across all of the domains. So because of the nature of our analysis, we decided to extract these, classify them as 0 parks, and then kind of bring them back later on in our analysis. We decided to utilize the multivariate clustering tool in ArcGIS Pro. And for this, we used the k-means clustering methodology. This is non-spatial, so it's attribute or field-based clustering. And for us, we use the various health domain scores as the input fields for this. And what this does is it collates attributes, combinations of attributes together to get different park types. And what's really great about this is it preserves the data. Unlike the park quality surveys, we don't get a single score. We get a single classification, but we can delve into all of that input data that went into it. So, what do our parks in Great Britain look like? So this here is the average park in Great Britain. So these are radar plots. So around the outside, we have our different health-promoting domains. And then the color in the middle, the bigger it is, the more of those domains it kind of satisfies. And the further that point of the shape inside is to those domains, the more it satisfies it. So these are the 5 park types we found in Great Britain, and I'm just going to start to talk through them now. So cluster 1, we can see that that's a relatively kind of low scoring park across the domains. But what's important to note, it doesn't score 0 overall because otherwise it would be classed as one of our 0 parks. In the red there, we can see cluster 2, and we can see that that's pulling towards the biodiversity domain. These are parks that tend to score high in the biodiversity area. We've then got cluster 3. So this scores relatively high across all of the domains, but lacks facilities. So it lacks sports facilities. So these are kind of our amenity-focused parks. We've then got cluster 4. These are our parks, these are our blue chip parks that kind of satisfy everything. And you can probably think of a park near you that kind of is that blue chip park, has everything and anything you could want in it. And then finally, cluster 5. Unlike cluster 3, these do have sports facilities, but lack those amenities. So I'm just going to show you kind of pictures of what these parks look like, and hopefully these can resonate with you of parks you are familiar with. So we've got low-level parks, so those are those parks that only have access to kind of one of those domains, and it's likely to be a bus stop. Here is an example of kind of just a green expanse of space in a housing estate. We've then got biodiversity parks, so these tend to have higher levels of tree coverage, and then potentially a water feature. We've got amenity parks, so they're parks that have attractions, but also have cafes and toilets. We've got high-level parks. These are those blue-chip parks that have access to everything. We've got sports parks, which pretty much says what it is. They have some form of sports facilities within them. And then we've got 0 parks, so those parks that have score 0 across all the domains. And I think what's really important to highlight here is we're not saying that a high-level park is better than a 0 park, even if that might be your initial perception. We're actually saying that these are different types of parks that provide different functions for the user depending on what they want to do. So if you're walking your dog and it needs to go to the toilet, a 0 park is the perfect park for you in that moment of time. Whereas if you want to go for a picnic or play tennis with your friends, it might not be the appropriate park for you. So once we'd established our 6 park types, so including our 0 parks, it was really important for us to make sure that people could understand what they were and also resonate with them. So what we did is we created a Survey 123 online form, and we sent it around kind of our wider research team. And people went out into the field to parks that they were familiar with and classified them based on a set of rules that we gave them. And this was really good, as it allowed us to do some sensitivity analysis to see how our cluster of a park related to someone's perception of the cluster of the park would be. And overall, this was really great because we could just, it kind of live fed it back into Pro, and we could just do the analysis kind of on the fly really easily. And what we found that actually the clustering worked well. I hope you can think of those parks and they kind of resonate with parks near to you. But we did find that sports parks were the hardest for people to define. And this was due to sports facilities. People might visit a park and not be aware of the sports facilities that are available there. And this was the case in one of the parks in Glasgow. There's actually a Frisbee golf course there. And unless you know what a Frisbee golf course is, you might not realize that sports facility is available. So what's really great about this project is we're able to see the different allocation of park types across Great Britain. So what this pie chart here shows is the percentage of park area which is occupied by the different types of parks. And we can see here that the most likely park, the highest scoring park, is biodiversity. So 27% of park area in Great Britain is allocated to biodiversity. And I think this gives kind of quite a nice snapshot on those park provisions. However, it's also really useful to break this down into other units. So what we've started to do is we've broken this down into local authorities across Great Britain. We'll focus on urban local authorities, and we've done this to 164. So what we've got here is the park provision for all urban local authorities across Great Britain. And I know that this slide's quite overwhelming, lots of pie charts, but I think it's a really good way to highlight the differences there are in terms of park diversity in these different local authorities across Scotland. And we can see we're not saying that we know the perfect combination of parks, but it's just a really nice way when maybe you're making decisions in the future to consider the types of parks you already have available to kind of your residents and how you might want to change those. So why is what I've talked about today important? Well, it's really important to know what we have to act as a baseline in order to improve it. Looking at a local authority level demonstrates the differences in park provisions present across Great Britain. And green space access, particularly urban parks, is integral to understanding how that influences our health and well-being. So what's next for this project? Well, firstly, we hope to be able to share the data so people like you can use it in your decision making. And we're also looking to link this up to 20-minute neighbourhoods so we can understand at a postcode level who has access to what parks and what combination of parks. And then we want to bring in integration of different data sets, such as social economic data. So, in summary, today we've explored the crucial role parks play in our society and how it's important for maintaining good health and well-being. We've talked about how GIS technologies has helped us understand park provisions and how we've quantified park types across Great Britain to understand this from kind of a diversity perspective at a local authority level. I hope you've enjoyed learning more about urban parks, and hopefully you'll take away today that urban parks are important to consider in decision making. Thank you.
Thanks, Jess, for showing us how spatial analysis can help us understand the value of the parks around us. Hi, everyone. My name's Isla Evans. I'm a GIS consultant, and today I'm joining Finn Riley, who's a customer success consultant. And welcome to our follow-up technical session on multivariate clustering and model builder in ArcGIS Pro. As I'm sure you all know well, many spatial problems mean we need to understand where patterns of data occur. Clustering is a useful method for this, as it helps us see visually where similar values are grouped together across different locations. One example of data that demonstrates clustering is deprivation data. This shows the relative comparisons between areas with high and low indications of deprivation. For example, these indications could be variables such as income, education, or health. Indices of multiple deprivation are then used to measure these patterns. This helps us understand why these patterns occur and also identify areas in need of additional resources. In this session, we'll use ArcGIS Pro to explore deprivation metrics through multivariate clustering. and show how you can easily share your results to others in a web application. Specifically, we'll guide you through the workflow we did to achieve this, which consisted of 4 main steps. First, we used ArcGIS Pro to perform multivariate clustering analysis. This helped us identify spatial and temporal clusters of deprivation across Scotland. Next, we created a repeatable workflow using ArcGIS Pro's model builder. We then published our results to ArcGIS Online so we could easily adjust our symbology. And finally, we built an interactive web application so that we could share our results with a wider audience. Now I'll hand you over to Finn, who's going to show you how we got started with this process in ArcGIS Pro.
Thank you, Isla. ArcGIS Pro offers over 2,000 geoprocessing tools split across 40 different toolboxes. This includes the Spatial Statistical Toolbox for analyzing spatial distributions, patterns, and relationships. While spatial and non-spatial statistics share concepts and objectives, the spatial statistical tools are tailored for spatial data, incorporating metrics like proximity and connectivity. Looking back at the deprivation indicators split by deciles, yes, these are simple, clear, and easy to interpret. But what if we looked for statistical clusters instead? Would the spatial distribution be similar? And would the results differ nationally versus locally? Using the underlying deprivation indicators from 2020 and ArcGIS, let's take a look. Here in ArcGIS Pro, I've got my underlying indicators from 2020 deprivation as a CSV table. And having a look at this, I can see that every single postcode zone referenced as a data zone has got about 34 individual metrics linked to each record. I want to turn this into a spatial data set first to start working with it. So what I've done up here, I've got my postcode data set across Scotland, and I performed a very simple table join. This just joins the 2 tables together by using a common field. So by selecting the data zone, it will pick out that data zone field in the CSV table, and it's always good just to validate your join, just to make sure that all the records have been linked together. So if we have a quick look, 6,976, and a join to a table of 6,976. Fantastic. So I've jumped ahead, and I've already done this. So what do one of these postcodes look like? Let's take a look at the East Cairngorms. So here there's that data zone record. I can see we're in Aberdeenshire council area. I can start to see some of those metrics like population, income, health, various drive times to key services, which is interesting to see for one record. What would that look like across the whole of Scotland? Well, I can use the data engineering tool to have a look at this. Here, I can quickly drag over different variables from my data set and have a look at the statistical variance or statistical metrics for each of those indicators. So let's have a look at what have I got? Total population, income count, and let's take one more, employment count. Now, when I hit calculate, it's going to give me some various metrics, as well as a histogram on the range of values within each of those metrics, which is quite interesting to see. But what's really helpful, and I've spent a lot of my time applying symbology, is you can just jump from one symbology to another by pressing the update symbology. And that shows me the distribution of values from employment count at the moment, but I can quickly jump over and see the distribution of income count, for example. And that's just applying a natural break symbology to that data set. So that's income count, one metric, one variable for the whole of Scotland. But what if we wanted to statistically analyze the clustering across Scotland using all of the indicators? How would we do that? What I'm going to do is use one of those statistical spatial analysis tools. So if I head to the Analysis tab under Tools, here I can see there's 40 different toolboxes. Now if I head to the bottom, there's that Spatial Statistical Tools, and I know that I'm going to be mapping clusters. Now, what's really helpful, because I'm not a wizard with any of these tools really, but I can hover over one of the tools and it gives me a quick summary of the tool to see if it's going to be useful for what I'm looking for. So, hotspot analysis comparison, comparing 2 hotspot analysis results. It's not quite what I'm after. What about multivariate clustering? Finds natural clusters of features based solely on the feature attribute values. Fantastic, that's what we're here for. So opening up the tool, I then have various different variables I need to set first to run this. And this tool is going to find different clusters based on the variables that I select, just as we've seen previously. So first of all, my input features is going to be my postcode data set. And this then brings forth all of those different underlying deprivation indicators. So for this, we're just going to select working age population, income count, and employment count as an example. Next, I need to set my clustering method. I have those two options of k-means and k-monoids. K-means, they're both similar algorithms that generally produce similar results, but k-means selects the first seed feature at random, whereas k-monoids selects an actual input feature. So that would take one of the metrics from one of the postcode areas and use that for the first seed feature. I can then set my initialization method. This influences the number of clusters that are identified across the whole data set. But you can also set that yourself. Say you knew you wanted to look at 5 different clusters, for example. Finally, some output tables are created, so I just need to give that a name. And I could run this tool, but it takes about 2 minutes, so here's one I made earlier. Now we can see that 3 different clusters across Scotland based on those underlying deprivation indicators have been identified. But why is that? We can see why in the pseudo-f-statistics chart. This shows me that the highest peak on my chart is 3. And that just indicates that 3 clusters is best for distinguishing the different variables into clusters across my data set based on the variables that I've selected. The next graph that's generated is the features per cluster. This lets me see how many of those postcode areas have been assigned to our 3 different clusters. So for example, cluster 3 is just over 3,500, whereas cluster 2 is just over 1,000. Now, finally, the multivariate clustering box plot graph. Now, this is my favorite, because here we've got those 3 different indicators, so employment count, income count, and working age population. I can see the distribution of values for every single category. So, for example, I had the minimum and the maximum value as a standardized value for employment count, and again for income and working age population. And it shows me where the average postcode feature fell for each of those variables. So for cluster 3, it had the lowest standardized value across each variable, whereas cluster 2 had the highest. What you can do is go one step further and select a side-by-side view. Now I can see the specific banding quartiles of where the distribution of those standardized values were. So cluster 3, for example, had quite narrow distribution of values for the postcode features, whereas cluster 2 had quite a broader distribution of standardized values. So it's interesting looking at this across the whole of Scotland. But what if we wanted to analyze this more locally? Say we wanted to look at the Central Belt, for example, or more specifically, analyze specific council areas, looking at deprivation specifically to that region. Well, we need to repeat the same workflow again and again and again, which might get a bit tiresome. So what we can do is use Model Builder to create a repeatable analysis workflow that strings together geoprocessing tools to make an easily repeatable tool for other users. So the first section takes a CSV table of deprivation indicators and joins this to the postcode feature class and applies an expression that then selects the specific council areas that I'm interested in analyzing. Here, for example, I've got Aberdeen, Edinburgh, Glasgow, and Dundee. I've then used an iterator, which repeats or loops the next steps over and over. This particular iterator is set up to select the specific council areas one at a time, so only the downwards workflow, i.e. in this case the multivariate clustering tool, is repeated. This means the multivariate clustering analysis will only be analyzed for that specific individual council area to identify clusters specific for that region. Finally, up here, I've also got what's called an inline variable substitution. This is just a quick trick to save me a bit of time at the end. So it takes the input feature or council area that I'm analyzing. So for example, I've got Glasgow space city. And using a really simple syntax, it just takes that space and replaces it with an underscore. So then I can use that string as a file naming output at the end. So that the clustering output for Glasgow city will be named multivariate clustering output underscore Glasgow city. And that's just a quick trick, saves me a bit of time. Now, I've created this in Model Builder, but I'd like to create this as a tool that someone else could use. So I've set the input indicator CSV table from 2020 as a parameter, the expression, so the user can select the specific council areas that they want to analyze as a parameter, and also the output file geodatabase. What's worth also noting is we've set the clusters to 4 to look at the higher and lower regions in this particular tool. So Isla, what does that look like?
Okay, so now that I have the model, I know I want to run it over specific areas in Scotland. So to do that, I'm going to open the model as a geoprocessing tool in the catalog pane. I can see here I have the correct geodatabase for where I want to export the results to, and I have the year specified for the data I want to run the model on. All I need to do is write a definition query. So I'm going to select where council area includes the values of Aberdeen City, the City of Edinburgh, Dundee City, and Glasgow City. And what this will do, it will just select the postcode areas within these council areas to run the model on. Now, running the model is going to take a couple of minutes, so like Finn, I'll show you some outputs we created earlier. You can see on the left here that individual outputs have been created for each of the 4 cities, and the clusters will have been made locally within them. I'm happy with these outputs, and I know I want to share them with others in a web application, so I'm going to need to publish these to ArcGIS Online. To do that's pretty simple. All I need to do is go to the Share tab and select to share these layers as a web map. I'll make sure I'm happy with the name, and I have the ArcGIS Online account selected for where I want to publish the results to. I can also analyze the layers at this stage to make sure there's no issues with them before I publish. Okay, with our data now in ArcGIS Online, I now need to symbolize it for my audience. Because the outputs were created individually and independently of one another, this means the clusters within them cannot be compared directly. I can make this simpler and easier to understand for my audience by using different color schemes for each of these 4 layers. However, I can also make this process a bit simpler for myself as well by using the hue rotate effect. So you can see here that for Edinburgh and for Glasgow, I'm using the same base color scheme. If I zoom in, that'll be easier to see. But for Glasgow, what I'm going to do is go to the Effects tab and go to Hue Rotate. And this will allow me to easily adjust the colors while keeping them tonally consistent with one another. At this point, I'm also going to change my base map to the dark gray base map, because this will remove any unnecessary information. And with my 4 city areas symbolized, I can save my map and then open it in ArcGIS Instant Apps. Okay, we're in Instant Apps. You can see here we have a lot of different templates that we could choose from. However, I know that I want to use the Compare template, which is currently in beta. The reason I'm choosing this is it will allow me to view the 4 different city areas simultaneously within one application. I'll walk you through how I'm going to set this up. So all I need to do is select the number of maps that I want to see, and bear with me, I will be repeating this 4 times. But the process is just to select the web map we've just created and configure the views. So for this first view, I'm going to zoom into Edinburgh, set the view extent and save. For my second view, I'm going to go for Glasgow. So we'll just zoom in there. Set the view extent. For map 3, I'm going to go for Dundee. So we'll just the exact same process, select the web map, zoom into Dundee, set and save, and then final one, map 4, we'll go for Aberdeen, which is our last city. So I'll just zoom into there. And the good thing about Instant Apps is that it has express settings, so I can run through these quite quickly. I know I want to use the scale bar, and I'm going to select the dark mode to stay in theme with our base map. But overall, that's all I needed to do to set up this web application. It only took me a couple of minutes. If you did have a couple more minutes, though, you had some more time, I can show you some ways that you could present this data differently. So you can see here what I've done is I've used the portfolio template to embed a couple of different applications. This first tab, you can see the Compare template application that we just made, comparing the 4 cities. So if I zoom into Edinburgh and Glasgow, you can compare how the clusters differ spatially between these 2 areas. What I've also done is I've used the media template, which contains a slider functionality. What we've done here is we've compared the data when we ran the multivariate clustering tool across data from 2016 and 2020. So if I just show you how this slider works quickly. And if I direct your attention to this West Coast area, you can see this is quite a nice example of how the clusters change over time. And if I can also show you Glasgow as well in the Central Belt. However, what we've also done, speaking of Glasgow, is compared the layers using the media template again, when we ran the multivariate clustering tool across the whole of Scotland versus just Glasgow postcode areas, which is what you can see on the left here. So if I just show you how this compares, you can see here that the benefit of running the model over specific areas is you get multivariate clustering that is specific to that area. So that's all of our web applications made, and I'm ready to share these with a wider audience. I'll hand you back over to Finn, who's going to summarize the journey we took so far.
Hopefully today, we've given you an insight into the statistical capabilities within ArcGIS and the potential value of looking at statistics geospatially. We've taken deprivation indicators and analyzed these using the multivariate clustering tool in ArcGIS Pro. Analyzed clustering both at national and local level, and made a really easily repeatable analysis workflow with Model Builder that others can use to easily replicate. Taking things to ArcGIS Online, we then published those results, applying meaningful symbology, and quickly developed an interactive web application using a combination of instant app templates. By sharing these apps, a wider audience can then review and make decisions based on our analysis. That brings our session to a close. But thank you for joining us today, and we encourage you to explore and use these capabilities within your own analysis workflows and mapping applications. Thank you very much.